Hey, what's up everybody? Welcome back. In this question, we have to graph each of these two functions and their respective parent function as well. Starting off with part A, we got y is equal to root 3 minus 3x plus 1. Well, what's the parent function? Parent function is just root x. So notice that usually the x is here, closer to the left side. So what we want to do first is we want to rearrange this. So we got negative 3x plus 3, right? 3 minus 3x is the same as negative 3x plus 3. And then we want that k value to be by itself. So we factor out a negative 3, and we are left with x minus 1 in brackets, and there's like a plus 1 here. Right, so now it's in the proper transformation format, and there's actually like a 1 in front here. That's the a value. So from here, we can tell what's the a value. The a value is 1, k value is negative 3, the d value is positive 1, it's always the opposite sign, and the c value is positive 1. So what we're going to do is we're going to take the parent function, root x, and then we're going to transform the points. So points we could use here are 0, 1, 4, and 9. That's always the points that I use, the x values that I use for the parent function root x. So I got 0, 1, 2, 3. And then we're basically going to take those points and we're going to transform them. So putting it through the transformation formula, which is x over k plus d for the x values, and then ay plus c. So x over negative 3 plus the d value of 1. And then the a value is 1, so we're multiplying all the y values by 1, and then just adding that c value of 1. So it's just basically y plus 1. Right, so 0 divided by negative 3 plus 1 gives us 1. 0 plus 1 gives us 1. 1 divided by negative 3 is negative 1 over 3 plus 1. That gives us 0.67. And then 1 plus 1 gives us 2. And then 4 divided by negative 3, negative 1.33 plus 1 gives us negative 0.33. And then 2 plus 1 gives us 3. 9 divided by negative 3 gives us negative 3, plus 1 gives us negative 2. And then 3 plus 1 gives us 4. So right there, those are the transform points for the function that we are working with. And the trick in this question is you wanted to get the function into proper transformation format in order to get the proper transformation values. So now we can just take this and we can graph this. So I'm actually going to erase this here. And then I'm going to plot some points over here. So let's actually go up by, so this has been compressed a lot. So let's go up by 0.5. So we got 0.5, 1, and we got negative 0.5, negative 1, negative 1.5, and then negative 2. And then we got 1, 2, 3, 4. So 1 and 1 is over here. 0.67 and 2, that is like over here. We've got negative 0.33 and 3, which is up here. Then negative 2 and 4, which is there. So this looks like that, right? And then the transformed or the parent function would look, actually, you know what? Let's just draw it on a separate grid. Basically, the transform function, you know how it looks. It looks like that, right? It would be a lot larger than this because I really zoomed in the scale here, the x value scale. Usually the x values are going up by 1s when I'm plotting the parent function. So it would be a lot larger than this, but I'm just going to keep the transform function on one graph and then the parent function on a separate graph. So basically we took the parent function and then we compressed it by a factor of 1 over 3, horizontally compressed it. We also flipped it in the y-axis because that k value is negative. And then we shifted it 1 to the right and then 1 unit up, that c value of positive 1. Right, so that there is your transformed function. Okay, moving on to part B. What is the parent function we're dealing with here? Well, it's y is equal to absolute value, x. And like over here, you want to rearrange this in proper transformation format. So you want to have negative 2x plus 6 plus 1. So this would be negative, and then if we factor out a negative 2, we'd end up with x minus 3. This would be plus 1 right there. So from here, easy to tell what's the a value, what's the k value, what's the d value, what is the c value. The a value is negative 1, k value is negative 2, d value is positive 3, c value is positive 1. So we're going to take the parent function, absolute value x, and its table, the table that I personally use is this one. And then we're going to transform all the points with that transformation formula. So x over k, so we're going to take all the x values, divide them by negative 2, and then add the d value of 3. Going to take all the y values, multiply them by negative 1, so we'll have negative y. And we're going to add that c value of positive 1. So starting off here, negative 2 divided by negative 2 is positive 1, plus 3 gives us 4. Negative y plus 1, negative 2 plus 1 gives us negative 1. Negative 1 divided by negative 2 is positive 0.5, plus 3 gives us 3.5. Negative 1 plus 1 gives us 0. Then 0 divided by negative 2 plus 3 gives us 3. 0 times negative 1 plus 1 gives us 1. And then 1 divided by negative 2 is negative 0.5 plus 3 gives us 2.5. And then 1 times negative 1 plus 1 gives us 0. And then 2 divided by negative 2 is negative 1 plus 3 gives us 2. And then 2 times negative 1 plus 1 gives us negative 1. So notice how this is symmetrical, the y values. So the y values here should be symmetrical as well, which they are. So now I could just take this and plot those points. So let's draw a graph here. So let's do 1, 2, 3, 4. And then let's do 1, 2, 3, 4. 1, 2, 3, 4. Right, so 4 and negative 1, that is down here. 3.5 and 0, that is here. 3 and 1, that is right there. 3 and 0, that's over here. Or, sorry, not 2.5 and 0, rather, which is here. And then 2 and negative 1, which is over here. So basically, this function looks like that. So that's the transform function. And then the parent function has a vertex at 0, 0. We got 1 and 1, 1 and 1, 2 and 2, negative 2, and positive 2. So in this case, because the scales are not too off, we can graph both the parent function and the transform function on the same graph. Right? So this is the transform function. So we took this function here, compressed it by a factor of 1 over 2, horizontally compressed it. That's why this one's a little skinnier. Reflected it in the x-axis, also reflected in the y-axis, but this negative, whenever there's a negative k value for an absolute value function, doesn't really have any effect, because if we flip this in the y-axis, it's still the same function, right? It's basically because if the k value is negative, the absolute value of a negative just makes it positive anyway. And then we took it, shifted it 3 to the right, and then 1 up. And that's how we ended up with that function, right? So that's the sketch of that. And then that is the sketch of that. Just remember, for these functions, if you're given them in a different kind of format, rearrange it so you could get it in proper transformation format. So you can get those transformation values pretty easily.